Plotting graphs. Graph of concentration of the reactant versus time. We start with the highest concentration of the reactant. Hence, the reaction rate is the greatest at the beginning of the reaction. As the reaction proceeds, the concentration of the reactant decreases. As a result, the reaction rate also decreases. Ultimately, the reaction runs to completion as one of the reactants run to completion. That is the limiting agent. A limiting agent or a limiting reactant is the reactant that is completely consumed first. It indicates how much product can be formed because of reaction cannot continue once the limiting reactant is finished. Graph of concentration of the product of the reactant against time. At the start of the reaction, there is no product, hence the graph starts at 0. As the reaction proceeds, the concentration of the product increases, hence increase in the reaction rate, until one of the reactants go to completion, that is the limiting agent, when the reaction stops. Both graphs are curved. To calculate the instantaneous rate of reaction, that is the rate at a particular point in time, we draw a tangent to that point on the curve. The steeper the tangent, the greater the rate of reaction. Graph of change in surface area against time. Both small marble chips and the large marble chips have equal mass. The smaller chips has greater surface area, hence greater rate of reaction, as shown by the greater slope of the tangent at the same time. And since the initial amount of both chips are the same, the small chips will go to completion before the large chips, but the amount of the product will be the same at the end of the reaction. Graph of the amount of the product against time at different temperatures. The higher the temperature, the higher the reaction rate. Hence, in the same instant of time, the amount of the product is greater with the higher temperature and the steeper slope and runs to completion earlier. Note that this summarizes the three factors.